Okay, points of intersection. So similar to what I did last time, watch out for your algebra for these questions. So it's saying that this line intersects the equation of a circle. Where could they possibly meet? So when you see this, you should be thinking substitution. Okay, so I have to substitute and factorize, similar to what we did for the last one with the tangent. But instead of getting two equal roots, we'll get two different roots. So let's just substitute that in. And again, you might need to rearrange this to make it a nice substitution. In this case, we don't. So let's go for it then. So I've got x, take away 2 squared, plus 3x, because y is 3x, take away 1 squared is 25. So this comes out as x squared take away 4x plus 4. And for this one, I'm just going to have to do, I'll do it over here. I'm just going to have to do a little table because I always make a little mistake when the numbers are a wee bit bigger than just that. Some of you don't need to do that. I like to just be safe. In an exam, I suggest you do it as well, because again, the clearer your working is in the exam, the easier it is to check it as well. Okay, so plus, and that's going to be 9x squared, take away 6x, plus 1 is 25. So we're going to get it onto one side, get it equal to 0, and factorise. And again, just like last time, if we can't take a nice common factor, we've probably made a silly mistake somewhere. So x squared, so what have I got? I've got 1 here, and I've got 9 here, so I've got 10x squared. Very good. X's, I've got negative 4, negative 6, so I've got negative 10x, and I'm going to be equal to 0. In terms of numbers, I have got 4 here, I have got 5, but I'm also going to take away the 25 as well. So really what I should have just said, well, we can imagine, so it's 5, take away 25, so it's negative 20, yeah, by pulling this one to this side, so negative 25. So 5 take away 25, negative 20, and we're thinking, yep, that was pretty good. I can take out my common factor of 10, so I've got x squared, take away x, take away 2 is equal to 0. So I'm trying to factorise, add to negative 1, multiply to negative 2, so I've got x, and I think it's going to be negative 2 plus 1, that's good to me, equals 0. So I've got a solution of x is 2, and I've got a solution of x is negative 1. Excellent. So it does cut it twice. If you didn't see the sketch, that covers. If they were equal, you could say I've got two equal roots, therefore it's a tangent and it meets at one point. And the way to work out your y value is just to sub it in to the equation, the easiest equation. So 3 times 2, so that's equal to 6, and y is equal to 3 times negative 1, so that's negative 3. I just write them out as a coordinate at the end. So you've got 2, 6, and then you've got negative 1, negative 3. That, for 5 marks, is absolutely stunning. Can't believe you're getting that, but okay. Yeah, not bad, eh? So, note to substitute and just taking your time. I think this is the bit where most candidates would make a small mistake. And you know you made that mistake because see here, you'll have some weird numbers, it won't factorise, okay? So, they're not trying to test you on some crazy factorising, so look out for that common factor. This question, so getting a little bit trickier now, trickier, but still about intersection. So we've got the point P. Now, I've not said this in the question, but the point P is on the circumference. I don't know why it doesn't say that, but it should. And we've got a circle C. Okay. So there's our P over here. So that's 4 and K. And we've got this circle where the centre is 1, negative 2, because we just changed the sign of this bit. And the radius is going to be 5, isn't it? So I can mark that on as well. The radius is 5 because this is r squared. So show that the distance between P and C, so show that the radius is 5, show that that's given by this equation. Okay, fair enough. So really what that is Pythagoras, isn't it? And I'm going to just leave that as 5 squared. Yeah. So a squared plus b squared should equal 5 squared. Yeah. So my a squared would just be 4 take away 1, so that'd be 3 squared. And my height here, this is what people don't like because it's a k. So remember you did 4 take away 1, you're doing the difference. So the difference is 4 take away negative 2 squared. And this is the tricky bit. So people don't really like that. They're kind of saying to themselves, oh, wait a minute, is it 2k, is it 2 plus k? But it's the difference, yeah? I did 4 take away 1 to get me this distance. So I'm going to do k take away negative 2 to give me that distance. So then I'm saying that k plus 2 squared, because the two negatives there will make it positive, plus 3 squared is going to equal 5 squared. So that's k squared plus 4k plus 4 plus 9 is going to equal 5 squared. I'm just going to check to see what form they had it in. So the distance was 5, no problem. So k squared plus 4k plus 13 is equal to 5 squared, and the distance is going to be the square root of that, isn't it? Because the distance is the radius, which is 5. You know, you could have actually maybe you're better off. You know what? Yeah, maybe you're just better off instead of saying 5 squared, just saying the radius squared. You know, yeah, equals the radius, and just saying that the distance would be the radius. You know, so not a bad question. It kind of reminds me of the quadratics where we're doing the less than or equal to stuff a little bit. In this case, it was kind of equal to. We didn't have to factorize or anything, but similar, a wee bit of that, we were effectively Pythagoras. But yeah, the thing to get you started with this is a little sketch. I think it should have said that point P was on the circle, but anyway. So yeah, that's a little bit of a thinker. And then this is where we go right into the quadratics. Hence, let's find the range of values of k such that p lies outside the circle. Range of values such that p is outside the circle. Okay, so let's move over here for this bit. Such that it's outside the circle. So what does that mean? Well, let's say we've got our k squared plus 4k plus 13 equals r squared. Okay, so that was this bit here. Now, if it was on the circle, we'd be saying, well, k squared plus 4k plus 13 has to equal 25. That'd be on the circle. But we're saying, well, what values would mean it's outside the circle? Well, that would have to mean then that k squared plus 4k plus 13 take away, well, I'll say take away 25 is equal to 0, so let's do this first bit, sorry. So k squared plus 4k take away 12 is equal to 0, so that is still on the circle. So I should rearrange it into this form first, on the circle. But what if this value here was bigger than 0? That would mean we're slightly outside the circle. We've gone beyond this radius, yeah? In the same way that if this value was less, we'd be inside the circle, okay? So, I mean, I could probably, yeah, we could come back to this actually. If you think on it as lengths, that's probably the best way to try and visualize it. I'll leave that just now. So the 25, we're happy, we can visualize that this is the radius squared, that's fine. But think on that as a distance as well. That's just another way of writing this distance, you know. And actually, at this point, I probably could still say, so if this distance, yeah, that's just another way of saying the distance. If that distance becomes bigger than 25, it's obviously outside the circle, isn't it? Yeah, that's now outside the circle. So just try and imagine that this is another way of saying the length. Like, that's another way of saying the length. That's the radius squared. That's just another way of saying the radius squared, but in terms of k. And then you want to rearrange to make to get it to be equal to 0. So take away 25 from both sides, and then it's our factorising. At this point, I want to find the roots. Okay, so that's why I'm putting equal to 0. So it's k take away 6 and k plus 2. With no, k plus 6 and take away 2, sorry. So I'm trying to find the roots. So k is equal to 2 and k is equal to negative 6. There's my parabola. So what values here are going to give me k squared plus 4k take away 12 greater than 0? When is it greater than 0? It's greater than 0 up here, and it's greater than 0 here. So it's when k is greater than 2, or when k is less than negative 6. So very similar to the quadratics equations we did before. It's just trying to maybe visualize that. It's a little bit funny. So this is, don't forget, that's just a length. That's another way of saying length. So it makes sense to say, well, if that length is bigger than the radius, I'm going to be outside the circle.